so.
Okay. Week 1, this is EST-101. And we're doing a review of the stuff we had last semester. I'm going to focus on the main things that I want you to remember because you are going to use them. So we talked first about Ohm's law. Everybody? What's in the top?
Voltage.
Volts. And resistance. This is volts. Relate. This is ohms. Amps. From top to bottom, we divide. So if you want to find the resistance, you cover the resistance, you divide voltage by amperage. To find the amperage,
Voltage divided by.
voltage divided by resistance. To find the voltage,
Multiply.
multiply simply resistance by amperage. So that's Ohm's law. Hopefully you remember it. It's over there, it's gonna stay over there. And this is how we apply it. Why would we need it? To find one of the components and to try to verify the system, make sure the amperage that you have is correct. If you're drawing too much amperage and wanna see how much amperage you're supposed to be drawing, it's good to know the basics of Ohm's law. Second thing is power law. That's important also to calculate cost, to calculate how much power you're going to be withdrawing, see if the circuit can handle the amperage draw or not. So that's the power law here. Power is in what unit?
Watts.
Voltage and amperage. Same thing goes. Amperage is power over voltage. So some equipment do not tell you how much amps do they draw, and you want to know because what is the limit on your circuit? Any circuit inside the house generally? You should know. 15. So if you have a machine that says it's 3,000 kilo or 3,000 watts, how am I going to know if the circuit can handle it or not? I'm going to convert and see how much amps it will draw. And if it's more than 15, then I cannot install that equipment. So this is how you get the amps. Example. How much a microwave consume? 2,000 watt? 2,000.
Between 2 and 3.
Yeah, let's say 3,000. How many amps at 110 volts? So I'm going to go and say the amperage will equal 3,000 over 110. Here's my calculator.
It's less than 30.
This is really bad calculator. I don't want this calculator. You got 27 amps. Is that acceptable? No. Probably it's gonna, if you're gonna have an equipment that draws this much, it will have its own circuit breaker, and probably you're gonna go with 30 amps. And we do have some of those. We have 20 here. This is 50 amps, 50, and it's 100 amps. So you gotta get a circuit breaker, especially for that equipment, and put it to the control panel. Example, the clothes dryer, washer, some dishwashers, and if you have industrial size microwave, so probably gonna have its own circuit breaker. So, what would you think happen if you have 220 volt? So,
With less amps.
Yeah, smaller load
Yeah.
circuit.
So probably it's gonna be half that, which is 15, 10, 12, 13.
13.5.
One, 6, 3 amps. So that's why, so if I have 220 volts, probably I can have less amps. And that's why in Europe and South America, I don't know, some countries are different, but everybody uses 220. We are the only one who use 110 commonly for all appliances. That's why in your phone charger, you'll see it's between 110 and 220. We try to accommodate more countries. More places. So I'm gonna lower the load in the circuit, which is better. Instead of drawing 27, I'm gonna draw 13 amps. The circuit gonna be cooler. The wire could be smaller.
50 amp double pole breakers.
Yeah. Relay.
You know, I thought it started at 11:15, but
It doesn't. Say sweet, it's okay. This is how we use power law to get the amperage. If I want to find the voltage out of the power and amperage, it will be power over amperage. If I want to find the resistance, that's another story. But let's stick to this. I have to find the power is amperage times this meter system.
I times E.
VA.
Oh,
Which is, sometimes A is referred to as I, and this is E. Different notation, but it's the same thing.
Yeah.
Old school.
Some books have E.
Some books have E, some
I is A.
books have,
The same thing.
so this is how we manipulate both of them. If I want to find the resistance out of this law, we cannot, so we're gonna find the voltage and the amperage. Then we're gonna go and use this law here. This is voltage over amperage.
What are
we
we
can
trying to
use
find?
both interchangeably.
Trying to find
So we
voltage.
covered Ohm's law and power law, how you remember that. It will come into play sometimes to give you an idea how much power you should be using, what is the resistance you should be expecting, is it higher or lower, or whatever. So series circuit. We say the voltage. What happened to it?
Drops.
Yeah, drops. And resistance adds up. Current same. Okay. What do we use series circuit for? Two things.
Safety.
control.
Yeah, safety. And control. Give me an examples of control. Jason, example of control.
Control.
Yeah, something we use to control the circuit.
Relay.
Yeah, relay. And for us, for oil burners, if we want to control when does the burner comes up or off, thermostat, right?
Oh,
So, but relay is also considered some kind of a thermostat. So, thermostat. Relay. What about, remember in the board when we wired those 4 switches? One of them was what? Fuse, right?
Mhm.
So, that's also fuse. That actually, let's put that by itself. Safety. What about high pressure switches?
Any kind of switch.
Yeah. We have high pressure and low pressure. They can both be control and safety. So high pressure switch, low pressure switch. What else?
Timers?
We'd have timers.
Timing relay, maybe? Oh, you got relay already.
We'll put timers. Why not? What else? Something we talked about last class that prevent against fire.
Oh.
Aromatic.
Yeah.
Vacuum switch, the one for the, for when you have the
The gas
induced,
furnace.
draft.
Exactly, yes. Vacuum switch. do your paper with that switch.
Okay,
I mean, a suggestion, yeah. Yes. Comments.
I will.
Firematic. So firematic, just so we remember that, what is the set temperature for firematic?
165.
165. 165 degrees Fahrenheit. This is for sure going to be a question on the oil burner exam. Remember that. The other dumb question they always put is all hydrocarbon material is consistent of what?
Carbon.
Huh?
Carbon.
And what?
Hydrogen.
Yeah.
Okay.
So remember that. They're going to ask this question for sure. They will say all hydrocarbon material are composed of what? Hydrogen and carbon. I'm going to write this down too. Write it down so you remember. What is hydrocarbon? Petroleum products, rubber,
Plastic.
plastic, gas. So all hydrocarbon is hydrogen plus carbon. Looks like that. C atom bonding with hydrogen. No, one bond. Sorry.
What is that, H-I?
No, this is the carbon atom. It has
What's
4 bonds.
What's above it?
H.
Oh, okay.
Yeah, so it's hydrocarbon. Or it could look something like that. C H, 1 H here, and another H here. So based on the composition of the hydrogen and carbon, we have more different products, different chains. So that's another question. The other question that's for sure is going to be on the exam is what are the elements of combustions? The equation of combustion. What do you need to make fire? So to make fire, fuel,
Oxygen.
fuel is carbon. So fuel,
Oxygen.
air or oxygen,
And heat.
and heat or a spark. The products, heat, carbon dioxide, and water.
Carbon dioxide is the result.
Yeah, it's the product
Oh, yeah, the product,
when
okay.
it comes out. That's one of the questions that they always ask. Let me remember the other ones. It will come. It will come. So I'm going to keep repeating this thing over and over. So by the time the exam comes, you will remember it. The other question that will always come. What is air composed of?
Nitrogen, oxygen.
Nitrogen, oxygen, nitrogen, and
Okay, percentages.
78% nitrogen, 21% oxygen, 1% other stuff.
Yes. So I'll write it down. So air, 78. We can say 80. If they give you 80, don't pick the number. Percent oxygen and
No, nitrogen.
sorry.
Nitrogen, yeah.
1% other stuff. Yep.
And 20% O2 and 1% other. And there's another 1% could be 79 nitrogen, but mostly nitrogen. So we're breathing mostly nitrogen. And huh?
That's the Skyjack that they took from back
That's
there.
your conscious talking.
I mean,
Is this gonna be long? Is this gonna be long? Okay. What are you guys doing? Just stop. Pick up all right?
Pull me in my wagon.
Huh?
Pull me in my wagon.
So mostly nitrogen, a little bit. Oxygen is 20%. And remember that because when you do the combustion testing, you gotta measure the oxygen. If you have less oxygen, means that you are burning the oxygen, which is your goal. So you want to burn more oxygen. It's very difficult to burn all of the oxygen. You're gonna burn most of it. So 15, 14%, that's pretty good. How much oxygen do you think you take with each breath?
A lot.
Not really. Out of the 20, maybe taking 5 an hour. 2 to 3% if your lungs are really good. If you're an athlete, you'll absorb more. If you're a smoker, probably take 1%. That's why you are short of breath, because your body cannot oxygenate quicker. Swimmers probably they can take one breath and they have like gills in there and all the oxygen comes inside. So that's why you want to have really good lung function. Okay, so we talked about series circuit, parallel circuit. Let's move on to some equipment. So this class is mainly about control, combustion control. We try to put more control so we don't have to be there turning the switches on and off. So the more control we have, the least human interference you have, and the less error we have. A lot of the issues now are human error. So we try to have more controls and more machines. And I lost my clicker. Fine.
You couldn't find it yesterday either.
It's okay. Things get lost. So solenoid valves is something we use a lot in our field to control liquid flow. We control gas flow. Basically, it's a valve that open and close. Completely open, completely closed, not partially. Remember this. Motors. We talked extensively about motors last semester. We took one apart, we put it back again. We know there's different types. Okay, we're done with that. You know motors, we have, what do we size motors on? When you want to go and buy a motor? What do you remember? Yeah, huh?
Power.
Horsepower. And what else?
RPM.
What else?
What's the frame?
Torque, which is torque, horsepower, what else?
You only see like single
Frame.
phrase.
That's another thing, single phase. What kind of power does it take? And what else?
Think about the hertz too.
Micro.
RPM. So when we go for, there's so many characteristics, but for us we care, we have to match the RPM, because if you don't match the RPM, you screw up the pump or whatever it's operating. So you want, if you look at this pump, it tells you that how much RPM it's supposed to be running with. So this one is 3,450 RPM. If you have put a motor that's different RPM, you're gonna overrun the pump and you might ruin it. So we wanna match the RPM, we match the horsepower, and we match the power intake. We talked about relays, and we said relays are switches that turn on another circuit. So we have a circuit, and there's a sub-circuit, and sometimes another sub-circuits. So relays. Relays are the basis of us doing control and logic. If this light turns on, then turn off the other light. So one thing will go on, and something will go off. So relays control things. If we look here, we have two relays. One of them will engage. So the relay is input, right? This is the sensor. Once this sensor actually is inside the tank. So it's inside the tank, it senses the temperature. Once the temperature is within those two limits, it will close the circuit and engage this relay. This relay will tell the connection here for the burner to turn on or off. So the relay has an input and does close a circuit. There's another one here. This one, once the water is between the limits, it will turn on the pump. So one to turn on the burner motor, so we need more heat. And the other one, when we have the heat, with heat satisfied, we circulate the water. So we have two logics in this aquastat.
So that's not just for the continuous heat on demand coil?
No, this is not for hot water. And actually,
That's
probably
not for hot water?
it is for hot water system.
For the, yeah, I mean before, I meant the hot water,
On demand.
On the, you mean, I know what you mean.
for your shower and stuff.
Yeah, so if you have an indirect water heater that is controlled also, that is heated by your boiler, you probably have one of those as well. So this will have a thermostat that will turn it on, and it also have an aquastat. So this aquastat will maintain the water inside the tank within those two limits, which is 140 and 180. So you're gonna take water from that into your shower. Once it drops down below 140, it will turn on the
What
boiler.
if you're not using your?
It's still gonna be maintaining its hot, and that's why you waste money.
That's why on
So
demand is
how
better.
do you eliminate the one for the tank? Is there just one wire to cut? Is it?
But no, this is gonna control the water. You need a different configuration. Because if you hot water coming from your boiler is gonna be on all summer, which is very consuming. So it's better for you to get an on-demand or isolated or separate indirect tank. Using your boiler for heating and also for hot water is good in the winter, but it's not good in the summertime. So you're better off updating the system and getting either a separate tank with its own boiler, or you get on-demand. I really like the on-demand ones. So here you see there's a lot of relays here that you don't see it anymore. So this is the future.
Oh, I've seen one of those replaced.
So there's no mechanical parts anymore. It's all
Transistor?
transistors or semiconductors or IC, which means integrated circuits. So they're very small, but they do the job, and they are very low voltage. Okay.
Is it harder to troubleshoot those boards than it is like an older circuit board?
Yeah, I mean it's not harder. You can condemn the board. No, it's not working.
Yeah.
Do a few functions, not working. You just change the board.
I'm saying to like test it with like your voltmeter and stuff like that.
You can know if it works or it doesn't work.
Oh, man.
If it does what it's supposed to be doing, that's good. Otherwise, just change it. But to go inside, it's really almost impossible to know which IC is there.
Yeah.
You have to take it to the electronic shop and they'll go trace the boards. And now they're becoming so cheaper that they don't even like fix them anymore. Like back in the days, those transistors get fixed. You will send your VCR to the electronic shops and they'll fix it for you, and they solder the small little IC in it. And it was fun and labor intensive, but they did that. But it was expensive. The first VCR was like how much? $2,000. You know what a VCR is. Okay, so relays, transformers. We're gonna use a lot of transformers. And what do? Lance, what does a transformer do besides Optimus Prime and Bumblebee?
The transformer provides electricity.
Yeah, it changes the voltage, either up or down, right? So this transformer here is changing the voltage from the input, which is what? How much input coming into here?
120.
120. And what does control usually take? 24. So we assume that this is 120 to 24. So for our purpose, usually it's going to be 24 for control. So 120 to 24. Sometimes you might have 220 to 24. But again, that's what we need control transformers for. Okay. We talked about that plenty last semester. I'm not gonna say too much, but we know the role of electromagnetism in electricity, right? And we said, based on the fact that when you run current through any wire, two things happen.
Get heat and
It
then-
heats up
Yeah.
and it gets magnetized. So based on that, people got really creative, and they're still getting creative by finding things to do with that two little facts. It's amazing how much things you can find. We have inventions all the time. So okay, magnets, let's get creative with that. They turn into a coil. You can use the magnetism to pull something, do mechanical work, or you can use the heat to heat something or actuate something or change the resistance. It's getting more and more involved. Now we have humidity sensors. When you do the sensor paper, you'll see how much is involved, how much it got involved and complicated, that we can even do oxygen sensor based on using zirconium. So, huh? Great, thank you. Appreciate it. Good man. So, zirconium reacts with oxygen. We're all guys here, it's okay. Thank you. So, zirconium reacts with oxygen and send a signal. Carbon reacts with vibration and send a signal. How did they do the microphone? How did the first microphone work? Same thing. You send the signal through small pieces of carbon. They vibrate.
Oh, and they come out as at the same frequency.
Yeah.
Yeah.
You did the speaker thing, and same thing, frequency, based on magnetism, vibration. Things change from one form to another. Okay. So we know magnetism basically is coils, motors, pulling, and we can make magnets using coil, or we can use permanent magnets as well. Solenoid valves. Again, we're going to use those. They can be very quiet and very sneaky. You don't know if it's on or off. We have a valve, let me see. This is a solenoid valve here. Very small. It can get very frustrating that you don't know if it's on or off. So some of the ways to do it, some people use a compass. You put a compass on it and turn it on and see if it moves or not. Is it on or off? So what it's doing is just a small little pin against the spring. So pull it up, pull it down. So we use that for oil. In gas, there's also a solenoid valve. Some of them are strong that you can hear it click. When you turn on your car, not completely, put it in ignition,
We hear a bunch of stuff
you're
start.
gonna hear tick, 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 a lot of clicks, things are getting ready. The pump is on, the oxygen is on, this and that. If one doesn't click, you're gonna get check engine light. So this happens. Check engine is the most frustrating thing.
It is.
But it's getting better now. With the new readers, it tells you at that day and that time.
That they come on more frequently now.
Yeah, yeah, and you can't pass.
Inspection.
Yeah. Motors, big motors, small motors, they all do the same job, which is rotation. They rotate things, and we will use motors. Where do we use motors? Huh?
Everywhere.
To turn.
Pump,
Over there.
inducer fans, compressors.
Draft.
Huh?
Draft.
Yeah, yeah. Inducer fans and so on. And again, we did talk about motors a lot, so I don't have to repeat, but basically they rotate and they have different polarity. And as Kevin said, they can be single phase or three phase. We can use a capacitor to start the motor, and sometimes the winding start the motor as well. Okay. Let's pause. Let's take 7 minutes.